Hello, so nice to see you again. Welcome to our topical solution series for IGCSE at Maths 0606. The topic we're going to focus on in this video is factors and polynomials. The question we have chosen to solve and study is taken from October-November 2012, paper 2-1. Let's go to the question. Question number 10. Section 1, the remainder when the expression x cubed plus 9 squared plus bx plus c is divided by x minus 2 is twice the remainder when the expression is divided by x minus 1. Show that c equals 24. Okay. In this topic, we know that there are only two key ideas that we need to master. The first one is called factor theorem, and then the other one is called remainder theorem. The factor theorem, it just simply means that when you are given a factor, and when you take the factor and you equate that with 0, and you're going to get the root value of x. Then when you get the x value, substitute them into all the x appearing in the polynomial expression, you're going to equals 0, which means you will have no remainder when you take the polynomial expression and divide it with the factor. That is factor theorem. Now the next one is called remainder theorem. Remainder theorem is when you are given a divisor, and then from divisor you draw out the x value, and when you take the x value, substituting it into the various respective x places in the polynomial expression, and you're going to equate it to its remainder. And therefore, if you were to take the polynomial expression, divide it with the divisor, after all the stages of long division, you're going to conclude the remainder. And this remainder will be the same value that you get at the end of the equation when you substitute the x value. Well, with that said, we have concluded our quick revision on the factor theorem and also remainder theorem. Well, with that, let's go on with the solutions of this question. Okay, we're going to look out for a few keywords. The remainder. Okay, this is going to be the word that you wanted to identify and you wanted to pay attention to. With the word remainder, you know that you're going to use remainder theorem. The remainder, when the expression of such is divided by x minus 2. So we know that when the expression has been divided, you're going to get a remainder. So for this case, we're going to notate it as capital R. And you know that the sentence is not complete. In fact, it is relational to another division and another remainder. So now it says the remainder when the expression divided by x minus 1. And in other words, when you take the expression with the x minus 1, you're going to get another remainder. For our solution, I have notated it as R prime. Then with that statement given to us, we know that R1, okay, the R1, the first R is going to be twice of the second remainder. Okay, with that in mind, let's start our solution step by step. Okay, the first step we're going to move on is the divisor x minus 2. Then from here, we draw out the x value as x equals to 2. Yes, I know that you have observed the interesting notation here. The divisor having -2 and the x value will always have +2. So you will notice the value or the sign will always change. Now you take the x equals to 2, substitute them into all the x position respectively. Okay, and that's what we have done here. 2 cubed plus 9, 2 square plus b multiply 2, copy down plus c equals to the remainder notation that we have put in as capital R. Then simplify this. That's how you get them accordingly. Then gather the like term 8 plus 36, it gives you positive 44 plus 2b and then plus c equals to remainder R. Then you take the second divisor, the one that I highlighted with green, x minus 1. Then we draw out the x value. Yes, you notice again the opposite sign of the x value. We have x equals to 1. Substitute that again into the x position respectively. And that's what we have done exactly. And 1 cubed plus 9, 1 square plus b multiply 1 plus c equals to r prime. And that's the notation that we have chosen to represent the second remainder. Now simplify them accordingly, and that's what you get. 10 plus b plus c equals to r prime. Yes, now you're in good shape. Now we're going to fulfill the criteria given to us. The first remainder is equals to the 2 times of the second remainder. Now what we're going to do is just taking this, substitute it into the R. Now the 2R, yes, this is what we do, the 2R. So we're just going to take this and put down here. And then, so you have got for yourself the fulfillment of the criteria or information given to us. And now what we're going to do is we're going to expand, simplify, and conclude to our mission declared done shortly. Now we're going to have, well, on the left hand side, nothing much to be done. On the right hand side, we're going to expand the bracket and we draw out 20 plus 2b plus 2c. And we notice there are 2b both sides, and we will conveniently cancel it out. And then we're going to gather all the c together. That's what I've done. So I gathered the c together into 2c minus c. So this one, just bring that. And then, so the 20, I'll just bring it over. And that's how we get the c equals 24. Then successfully accomplish section 1 of this question. Now we go to section 2. Given that x plus 8 is a factor of x cubed plus 9x squared plus bx plus 24, show that the equation x cubed plus 9 squared plus bx plus 24 equals to 0 has only one real root. Well, now it has given us a polynomial equation. So what we're going to do is, in order to fulfill and to show that the cubic equation has only one real root, first and foremost, we need to break down them into the other root besides the x plus 8 given to us. How are we going to do that? Yes, that's what we're going to do. We're just going to fulfill the factor theorem. And why do we want to do that? Because we know that there is an unknown b. There's an unknown b that is still hanging around mysteriously, and we can't proceed until we able to find the value b. So with that, we're going to run the factor theorem to find the values of b. So with that, well said, we got the factor x plus 8. Then we draw out the root. Yes, this is the root, x equals minus 8. Well, that According to this statement, the x equals to -8 likely to be the one and only real root the cubic expression has. Well, hold on. We're just going to develop until we have enough evidence. Now, what we're going to do, after substituting the root into all the x position, that's where you have the x cubed, you have substitute into -8 cubed plus 9, -a squared plus b multiply -8 plus 24. According to factor theorem, you're supposed to equal to 0. And that comfortably give yourself the next steps of simplifying, expanding the cube of -8, and then expanding this, and you get 576, and then simplify this, you get -8b plus 24, and accordingly you simplify the like terms into 88 minus 8b equal to 0, and you go on and solving, you get for yourself at the b equals 11. And with that b, you have managed to obtain a completed polynomial, which is x cubed plus 9x squared plus 11x plus 24. Now you have got a completely free from unknown statement of a cubic equation. So now you can use the long division to find out what is the other factor besides x plus 8, the one that given to you. Okay, so this is how we move on by dividing using long division, taking the cubic, we put in the dividing notation. Now we're going to divide it with x plus 8. Now, in order to eliminate the x cubed, that's what we figure out that we're going to multiply it with x squared. Then by multiplying x with x squared, it gives us x cubed. Now we're going to multiply x to x squared, it gives us x squared. Now we're going to minus. True enough, you notice that we have gone the whole thing x cubed into 0, and then you're going to take 9x squared minus 8x squared, we got x squared. Then you draw the 11x down, then you're going to eliminate the x squared by getting the x multiplying another x that gives you positive x squared, and of course the 8 will also be multiplied with x to get positive 8x. Then true enough, when you minus this whole thing equal to 0, and 11x minus positive x 8x, it gives us 3x. Then now you have drawn down the positive 24, and by doing that, x multiply 3, it gives you 3x. 8 multiply 3, you get positive 24, and 3 now, after dividing this, there is no remainder, and that also the evidence that x plus 8 is the factor, because you have no remainder after dividing it from the polynomial. Now, you are getting closer to the conclusion. Now, your expression, okay, this expression, you have got this as given to you as equal to 0, okay, the one given in the question. Here we go. This is the one. So now your cubic can be now breaking down into two factors, the one given to you and also the one that you get from your long division. Now, in order to show that the x plus 8 is the only factor, and from x plus 8 you get the x minus 8 is the only root, we need to prove, okay, we need to prove that the quadratic has no real root. Well, in order to do that, well, we need to use another principle, which is we're going to call that, we know that we call that as discriminant. And that's what we have it here. In order to, before we go on, I would like to run a quick revision about what is discriminant. Okay, if we are given a quadratic expression, ax squared plus bx plus c, by taking their discriminant, which is b squared minus 4ac, when we got the discriminant equals to 0, we can conclude confidently that the quadratic has two equal real roots. And when we substitute the a, b, and c into discriminant, if we got a value that is positive, which is bigger than 0, and that we conclude that the quadratic has two real roots. And on the last testing, if we substitute a, b, c respectively, and we get the discriminant into a negative value or less than 0, then we know that it has no real roots. And what does no real root means? No real root just simply means that if you take the quadratic expression, you can key in the ABC into your calculator, and you're going to get the calculator displayed to you x equals to a solution or something displayed there with an I. That I representing imaginary number, that means the x is actually cannot derive into a real value. Okay, so that is what meant by the no real roots. Therefore, as of now, you have obtained a linear, yes, the one that given to you, and we're going to draw the a, b, and c value. That's what we shown here. A equals to 1, b equals to 1, and c equals to positive 3. Then we substitute them accordingly into the discriminant. Yes, the b we substitute here, b squared minus 4a and c, 4 times 1 times c. And we know that we have the discriminant equals to negative 11. And that shows us the discriminant is less than 0. So the quadratic actually has no real root, because it's not going to get any real roots, because it is the discriminant is equal to negative values. Okay, it has no, let me just correct this, it's supposed to be no real roots. Okay, now what we're going to get is, hence you have arriving at your evidence that the quadratic expression has only one real root, which is x equals to negative 8. So that's the only one real root that it's going to ever have for this cubic. Yeah, so that's the end of the solution for this question. Well, congratulations. Section 1, 5 marks, section 2, 4 marks. You have successfully run through the process and confidently pocketed 9 marks for the solution. All right, so congratulations for this time that we have run through together, learning the polynomial and factors, and looking forward to see you again in the next video. And until then, happy learning always. Bye-bye.